Let us first solve 0.04 times 2. I equals 60,000, since we haven't solved 60,000 yet. 2 times 0.04 is 0.08. Let us move to the back side since it is already full. I equals 60,000. Just copy the answer earlier, times 0.08. And 60,000 times 0.08 is I equals 4,800. Since the question is also asking for the maturity value, we'll also solve for maturity value. And the formula for maturity value is mg equals p, or principal value, plus I, or interest. And for the solution, just transfer the information that we have already gathered, the given information. Since we already determined P, which is 60,000, and I, which we have already solved for, which is 4,800 plus 4,800. And now we just need to add both of them, and the final answer will be like this: mg equals 64,800. This is the maturity value, 64,800. Do you now understand what simple interest is? Can you now identify and solve simple interest problems? I do hope that you've learned something from the lesson I've discussed. Since we're done with simple interest, let's move on to our next topic. Our next topic is compound interest. There isn't really much of a difference between compound and simple interest. It's just that compound interest is essentially interest on interest. The interest changes instead of staying fixed. For example, if you invested 10,000 pesos and the amount of interest you earn is 1,000 pesos, the next principal amount would be 11,000 pesos. Then the next would be 12,000, so on and so forth. And now, I will teach you the units in compound interest. Our first unit is future value, which is FV. M stands for number or amount of interest period in a year. P is principal amount, just the same as last time. And I for interest, R for rate of interest, T for term of loan, or for short, time. For you to better understand what M is, M can be determined by annually, which is a year, and when you will write M, if you have determined what M is and you will write it, it will be always in this form, where M is equals to the number of interest period in a year, like annually, semi-annually, quarterly, and monthly. Now that we know what the units are, let us move on to the formulas that we can use to solve compound interest problems. If FV is missing, then this is the formula we will use. P times 1 plus r over m raised to mt, and if p is missing, then fv times 1 plus r over m raised to negative mt, and if I is missing for interest, then fv, which is future value, minus p, which is principal amount. Now that we know the formulas we need to use, we can now easily solve example problems. But before I give you a problem to solve, of course, I would first solve an example problem for you to understand properly the compound interest. My first example for compound interest is Zeke invested $400,000 to an account that pays 8% interest that is compounded annually. What is the amount of money in the account after 8 years? And as usual, we should first identify the given information and properly sort them out. First, we should look for P, which is principal amount. Zeke invested $400,000 to an account. Then, principal amount is $400,000. And rate is automatically based on rate is equals to 8%. After identifying rate, it should be divided to 100 to get its decimal form. Then 8 divided by 100 is 0.08. Now we should look for T, which is time. An account that pays interest compounded annually. What is the amount of money in the account after 8 years? Since we now have M should be the annually, which is 1, and time should be 8 years. In this problem, they are asking about the total amount of money in the account after 8 years, which is the future value, or FV. To solve this problem, we can use a scientific calculator. Now that we have determined that FV is missing, we can now also determine the correct formula to use to solve this example problem. The formula should be FV equals P times 1 plus R over M raised to the power of M times T. And now we can solve the problem because we've already determined the given information and the proper formula to use to solve the example problem. To solve the example problem, to substitute the given information we have identified to the formula that we have determined. So it could be written like this: FV equals P, which is principal amount, that is 400,000 times 1, which is inside a parenthesis, plus R, which is 0.08 over M, which is 1. raised to the power of m, which is 1 again, times to the power of p, which is 8. Now let us solve. 400 times 1 plus 0.8 over 1 raised to the power of 1 times 8. First, let us solve the equation inside the parentheses. Since the equation in the parentheses will be solved first, FV stay, and I mean 400,000 should stay, and 1 plus 0.08 divided by 1 is still 0.08. 0.08 raised to the power of 1 times 8. Need to solve the next one. 1 plus 0.08 is FV equals 400,000 times 1.08 raised to the power of 1 times 8. Since we have already solved the equation inside the parentheses, let us now solve the exponent. FV equals 400,000 should stay the same. 400,000 multiplied to 1.08. 1 times 8 is 8. The next we should solve is 1.08 raised to the power of 8. Since we don't have any more space, I will erase this and continue here. FV equals 400,000 and 1.08 raised to the power of 8 is 1.85. I rounded off in the last two decimal digits, and 400,000 times 1.85 is FV equals 740,000. This is the final answer. To test whether you understood what I've taught in the video, it is your turn to answer the problem. Pause the video while answering the example problem, and when you're done answering, resume the video to see the final and correct answer. Are you done answering? Now, let us solve this example problem. We should always first identify the given information. Given. We have P, or principal amount, for 12 million pesos. P equals 12 million pesos, and R for rate is 16%, and divide it to 100 to convert it to its decimal point, which will be 0.16, and the next is time, which is 4 years, and M compounded annually, the M is 1. Now that we have determined the given information, we can now see what is missing